Right, hi everyone, thanks for coming along to the 6th IoT meetup. Glad everyone could make it in here today because we've had a last minute change of rooms because the projector in our room is broken. So folk aren't lost wondering about the tontine. Hopefully everyone's made it in here. So I'd like to start by thanking the tontine for hosting and Stream for giving the beers and Census for the pizza. So I put out an email just asking if anyone wanted to do a 5-minute talk in between the two speakers today. I don't know if anyone's actually up for it. I didn't get any response, but if anyone is, at the half-time point, I'll ask again if anyone wants to stand up and talk about anything you're working on, any ideas, any help you need from the community, then that would be great. So we'll get started. First up tonight, we've got Tony Boon from HP Aruba. And after that, we've got Stuart Kelly from Systolic. So they're both talking subjects, but it'll be interesting to hear. So I'd like to introduce Tony.
That one. Good to go? Yeah. Well, good evening everyone, and thank you Stephen for the introduction. As Stephen said, my name is Tony Boon. I'm delighted to be here this evening and present to you tonight. Give you a wee bit of background first of all. I work at Hewlett-Packard Enterprise and also Aruba, which is a Hewlett-Packard Enterprise company. Short disclaimer, I'm just here speaking on behalf of myself, not for the company I work for or for anyone else, just somebody who's now quite interested and really quite passionate about what's coming down the line in terms of IoT. So let's crack on then. So Hewlett-Packard Enterprise, as I said, for about 2 years now, came through the graduate programme and applied for a new role, which is the Aruba Network Specialist, covering all things wireless and wired. Speak to customers around connecting warehouses or shops or offices, whatever it may be. But what's recently happened is a new conversation has came about all around edge compute and new opportunities that lie for customers in that space and what they can do around this. And as I said, I went through the graduate programme. Before that, I'd done sociology at Strathclyde University, so I was fresh into IT, never mind IoT, but time was funny, and here I am talking to you tonight. So I thought, what better way to go and learn about edge compute than just throw myself in at the deep end, make myself go and learn it and present it to you tonight, and hopefully you'll all pick up some learnings along the way. So during studying this edge compute technology and understanding what this new model is, a lot of things came about and a lot of people were saying there's going to be a big revolution that's taking place. This revolution is going to change the way we interact, work, play, communicate, engage with society in general. It's going to change the way we interact with people, places and things. It's going to change the way people interact with IT, because IT is going to start converging upon the real world. It's going to start converging upon places that we never thought were possible before. And we've already seen this new wave of compute come into our actual daily lives. You think of autonomous cars, they're starting to come down the line. That's just a data centre on wheels, right? You've got a data centre in the sky with wings, that's a drone. And what's to come next? You could possibly have a data centre with arms and legs, and that's a robot. So this revolution that they're talking about is actually taking place, and it's happening now. So I want to describe to you what's actually taking place and how the world has changed. But before I do that, I want to talk you through how revolutions aren't a new thing. We see a number of revolutions up on the screen here. The steam revolution moved the world away from handmade goods to machine-based products in the 18th century. Electricity came in, that moved the world away, or actually was a second step from machine-based products to becoming the assembly line. Electricity came in, that was fueling the age of autonomous machinery and moving that one step forward. And today we're in the digital revolution of the 21st century. The digital revolution, and as you can see, each of these revolutions are fueled by one thing: steam, electricity or electronics and IT. The digital revolution is fueled by data. As it says at the bottom, is everywhere. We are part of this revolution because we are creating data every second of every day. Right now, we're creating data. I'm getting recorded, I'm getting filmed. That's going to get stored, it's going to get put online. It's going to be somewhere in the world. Right now, you're creating data just by sitting here. Your phones are recording your location to whatever manufacturer it is. Data is everywhere. And it's through the applications that are being created that we're developing that it's generating more data every single second. Now, as you can see, some companies are actually seeing data more, on balance with money or real estate, because the quote says there, it's no longer oil, but it's data that is really important now. And you think of the way these companies are operate. Without data, these companies wouldn't be able to exist. Data is. Think of Facebook, think of Google, Amazon, it all knows your history. You think of some of these companies, maybe Microsoft or Aruba, they want to send back the way we're using their edge devices, the way we're using what they consider their sources of money or their devices or their solutions. They're getting all that data that's coming from the edge, sending it back to the manufacturer, contextualizing it, analysing it, understanding it, finding out what our habits are, finding out how we use the data, finding out how we use the device itself to then produce the next wave of solutions, such as their products or their services or whatever it may be. But this is all at a time where data has been manually input by humans, and only now are we actually starting to see the autonomous wave that is coming now into the world. We look at this in oil rigs, on factories, I said, also cars as well. All this data is being created independent of any human interaction. It's all what would you say, autonomous is the word actually, and these machines are picking up data sets regarding pressure, gravity, braking, speed, temperature, and a whole host of other variable sets of data that the manufacturer wants to find out. And I remember what I spoke about, how it was the machine-based products, the assembly, now it's autonomous. Remotely, it's all done self-independently without human interaction, and that's happening. And that leads on to one example that we've got, which is the car. Think of all that variable sets of information and data that is being created. Sensors, cameras, radars. That's real world stuff that is happening right now. Real time, real data, real world examples. And what has to happen is this new model of compute has to emerge. It has to be at the very edge, not just outside the data center, but outside in the real world, so it can actually manage these sets of devices and devices such as this. Now, what is this new model for an IoT world? The world is moving to this IoT architecture. So how can this world cope? Quite basically, it's a question of the edge versus compute. Hopefully somebody knows edge here for WWE. I watched it as a Wayne, so hopefully there's a few laughs anyway, thank goodness that didn't go down like a lead balloon. But edge versus the cloud, right? This is the battle now that's commencing in this revolution. Where does the edge sit? Where does the cloud sit? Where should the data be? And somebody said to me, the best way to describe edge compute is you think you've got the flexibility of the cloud combined with the agility of distributed computing, where you move the compute power closer to the edge device that you're looking to extract the data from. So the flexibility of cloud, agility of distributed computing, closer to the edge device you're extracting the data from. And this idea of the edge compute isn't a new phenomenon. Rob Tiffany, his name is, in a presentation, it was The Cloud is Dead, Long Live the Edge. Anyone seen it? Cloud is Dead, Long Live the Edge. If you haven't seen it, I highly recommend that you go watch it. It's only for maybe 15-20 minutes. When this guy gives these examples, you're like, this is actually happening. The world is changing before our very eyes. It's fascinating. But he actually speaks about how edge compute model is not a new phenomenon. It started all the way back, you can trace it all the way back to the centralized mainframe days. You think of the mainframe itself, and you've got all the actors around the edge of the network, inputting manually into the network and their commands or searches or whatever it may be, and it's all getting pushed back to this centralized mainframe where they're using the resources and power of that. Then came the client server, and that allowed for local compute to be distributed, and all those searches and commands and actions of whatever those actors were inputting into the terminals were getting done locally. Then came the smartphone, the dawn of all these smart devices, and it turned our smartphones rather than to edge devices, but more like display vehicles. And Tiffany says that is because a lot of our searches and commands are done centrally, and the centralised repository is a cloud. You know, if you've got iPhone, it's the iCloud or a Google Cloud, whatever it may be. And rather than it being the edge device, a lot of this is done in the cloud. But what is happening now is that companies are wanting the edge device, the intelligence, the actionable understandings done at the very edge due to the amount of data that is being collected there. You think of the bandwidth issues, think of the amount of data that's going back, think of the cost that's taken as well, think of the time it's all taken. Organisations, they can't do that. You know, there's a saying in the work, and my colleagues up the back, they'll slag me for saying this, but the company says the future is for the fast. And it makes sense, right? Because that is the way companies will act. Those will be successful, the ones that are the quickest to market, the ones that can quickly analyse this data and react upon it. And so, let's go back to the car example, right? You've got this edge and cloud battle going on here. Tiffany also goes on to describe the criticality of certain edge devices. You think of this car, right? That's interacting with the world in real time. You think you've got sensors, radars, and cameras picking up stop signs, other cars going past it, it's got people on the road, animals, obstacles, everything, right? Think about the time it would take for all that variable data to be sent back to the cloud, understood, actioned, and sent back to the car to be actually, performed in the real world. The car is, well, Tiffany goes on to say, would have driven through the bus stop, taken out the people on the road and everything else, and the car would have just carried on because it takes too long for the car to understand. That's why this local compute model in the real world, where real-time data processing is taking place, and that's what this edge device is for. That's the way this critical edge device is going to operate. That might be an extreme example, right? And not many of us might here aren't going to be working on, the next wave of autonomous cars. But I seen this picture and I started thinking Grangemouth, Aberdeen, different places that we might be engaged in. Big petrochemical plant, right? You've got a lot of edge devices, machinery, that are, and a whole host of other data that's being collected from the pipes and the tanks there. Somebody here could code that will alert a technician to go out and fix a certain machine somewhere in that big mishmash of metal and say that the cogs are going to break because something's went into the machine. Now, the benefit to that is, through the sensors telling the technician that this is taking place, the technician go out before it breaks, save the company thousands of pounds in downtime, and still keep the company running 24 hours 7. The other one as well, you think of all these, as I say, think of all the liquid and all the gas that are going through there. You've got sensors now in these pipes and tanks that are doing edge compute, that are doing it right there at the very edge, so they can understand the pressure. Remember I said in that autonomous machine picture that there's different sensors picking up pressure. Sensors in these areas are doing that, and they're starting to self-reconfigure the valves and the nuts and bolts, independent of any human interaction, right there and then, real time at the edge. So, so there's no explosions or anything like that, but so the liquid or gas can just run freely if the build-up of pressure does occur. So there's things like that are taking place at the very edge. And the last one I'll give in this section is from Brian McGuigan, who spoke last month, 2 months ago, when he was here from Silver Spring Networks. He was talking about the IoT in the cities that are today, and that interested me. I thought, this is how we go to work, where we go out and shop or wherever it may be, and these are becoming smart cities. And I saw this great example, and I thought I need to use this one because and it was of the traffic lights. Traffic lights becoming smart edge devices. And how are they doing that? Because they've got the intelligence through the applications that the civic engineers or the developers built to put into these smart traffic lights. And what took place was a team won the cup or championship, and the next day there was going to be a big parade in the city. And the city knew there was going to be a lot of traffic, big surges, the traffic patterns from the previous weeks, and so they thought they had to be ready. But rest assured, the traffic lights were able to handle that demand because they were smart, and the traffic lights were talking to each other over the network. What then happened was, because they were edge devices and because they had the edge compute capability through the application running over the top of it, they could understand the traffic flows and react in real time. Now, they weren't sending all that information back to a centralised cloud or a centralised repository. They were actioning it and understanding it at the very edge, in the streets. That's pretty cool, right? And in the things that we were actually finding, the data sets that they thought, that is actionable, they done that and then send it back to the cloud once the traffic had died down and all the people were out actually at the parade and watching it. Now, what was taking place in this centralised cloud was that some information, that small part, was being actioned, further analysed, stored away, and if there was more actions to become, then it was to be sent back down, hopefully by the time the parade had finished, and it would allow the cars to move out the city more freely, because the edge devices understood that there was better ways to do this than what it had done before. And I think the benefit of the city is people come into the city quickly, they enjoy their day because they're not stuck in traffic jams, they're out watching their team, they can come into the city again because they think that's actually an alright city to navigate, they go and spend more money in the shops and so on and so forth. So you can see the edge compute brings, rather than sending all that sets of big data information that's been collected at the very edge because it would take too long. It's just another wee example. And as I said, those three examples, people, places and things converging on each other, on top of each other, and it's the people, places and things and the data that is generated through those people, places and things that will make the world more interactive, that will make the world, you know, the next big revolution, and it will fuel that revolution because of the data. So, the question is, why is somebody for Hewlett Packard Enterprise, Aruba, speaking to you this evening? Doesn't jump out to you, does it? You know, I'm a man for a GIF, right? I like a wee GIF now and again. It makes it a bit funnier, right? And we'll all like Nicolas Cage, don't we? So, why is somebody for Hewlett Packard Enterprise speaking to you? Well, let me tell you. And that's a funny picture as well. You're thinking, what is he going to say here, right? Because, as he said, I'm going to quote this, in a recent article, Hewlett Packard Enterprise is an IoT sleeping giant. You get it? An IoT sleeping giant that has impressive IoT blueprints for multiple verticals, doing multiple IoT workloads, driving multiple business outcomes. The depth the author has never seen before from any IoT provider. When I saw that, I was pretty impressed. Now, aren't you? And you were not expecting that, were you? So, let me tell you a little bit about Hewlett Packard Enterprise. HPE and we believe that the world is going to be hybrid, that the intelligent edge is going to unleash this industrial Internet of Things revolution, and that services are going to be critical. And so HPE and we ourselves are set to power the intelligent edge. So how do we do that, I hear you ask? Well, we do it through a full load of solutions. And on screen you can see the Edgeline Converged IoT solution, and we've got a number of other solutions where we've got rugged compute and storage capabilities, plus we've also got embedded industrial data acquisition and control systems that can sit within machinery that is in an oil rig, in a factory, in a petrochemical plant. You know, it can sit anywhere, and we've got that capability. Combine that with the long legacy that HPE has in the server market, with the Aruba acquisition, which is a mobility company, and a lot more, we were able to create these solutions and provide it to organisations and others such as yourself. And combined with that, what we've also got is a platform called the Universal IoT platform. And what this is an open source software platform where you can manage your tools for IoT, the devices, manage the network. And what it is, it's a platform that is so scalable that can allow any device to be connected to it over any network, cellular, broadband, LoRaWAN, Sigfox, and you name it, and it can run any software application that you put on it. And that's the Universal IoT platform. And just one example of what we're doing today is with Tata Communications in India. And what we're doing is we're deploying 250,000 in India for water quality and that's through Tata and the work that we're doing with IoT. So it just shows you the capability that somebody like Hewlett Packard Enterprise, and probably what you thought before tonight, Hewlett Packard, that just does computers, printers, mouse, and PCs and that. We actually do a lot more, and this is just one example. And that was done at Mobile World Congress back in February of this year. That was released. So there's a lot out there that we do. But we don't just do it ourselves. We do it with our partners, because partnering is so key and critical. Why should we try and do everything? Why not partner with those that have been in the market for so long and they actually understand the market as well, as long as ourselves, and we can intersect and understand who their customers are and such things. And one of these partners was National Instruments. We've got a whole host of others: Microsoft, PTC, Capgemini, a whole other load of companies. But National Instruments was the one that stood out to me, and it was because National Instruments are connected to enough every single analog sensor in the world. So why wouldn't we partner with them? Because that just shows you the amount of opportunities and the amount of the amount of cases that we can actually help customers in. If you think all these data sets are coming from these sensors at the very edge, we've got the capability to actually analyse and understand the data at the edge through our solutions. Now, I've spoken about the industrial Internet of Things a lot, and I've not spoke about the campus and branch level or the office space. And Aruba does a whole lot more. Aruba wants to transform, and is transforming, the way we operate today in our offices like this. We want to change the offices from just what it has been for so many years to what we call intelligent workspaces, or digital workspaces. And we do that, again, through a whole host of solutions, be it controllers, access points, sensors, beacons, switches, and everything else in that hardware portfolio. But what's the really interesting piece, and why I applied for the Aruba role, was because of the software element. It's called the and you're looking at security through a product called ClearPass, and access control solution. You're looking at management through cloud, which is central. But the real interesting one for me was the engagement platform, where you start talking to your customers and employees through a solution called Meridian. And my colleagues, again, will attest that it's a really cool piece of software. We were showing it in the work the other day, and just the way people over their phones and smart devices, when they walk into a building like this, you could have somebody walking, big television up there, and their name pops up because the system knows who they are. Just make a whole, make a big difference to somebody coming into an office. Now, the question is, we've talked the talk, but can we walk the walk? Yes, we can. All right. Now, how have we done this? We've done this through a few case studies, done this through a few companies as well. And the first one I want to speak about is with a company that had a refinery, and it's now called the Refinery of the Future. Partnered with National Instruments, and we partnered with a company called Flowserve that analyses the data that's coming out from the pumps and the oil, and it can start to look at how the oil's, what quality the oil is that's coming out from the ground. And we've done this to Refinery of the Future, and we've done this through a whole host of architectures. You can see the beacons and the sensors built into the machines. And the reason we've done this was because the company, for longer life in their assets, probably the hundreds of thousands, if not millions of pounds, they spend on all that machinery. They want to extend that. We can do that, as I've told you before, through alert to technicians to go and fix it. They want to save costs as well, so they're not going to be spending a whole host of new money on all those new machines. And then also the other one as well, they want to reduce that downtime, and we can do that through these solutions. But it's key that the partnerships are there, and that's why we need people that are even here tonight, or we need the next wave of partners, because only through partnership and through working together and collaboratively that we'll be able to achieve such things like this. The real one, the end one that I want to speak about, is the Levi Stadium. And the Levi Stadium was the stadium that was holding the Super Bowl in America last year. I really like this one because I can relate to it. If you go to the football games or whatever it may be, you can actually start seeing yourself doing things such as this. You think of all these, thousands of fans, and think of the millions of people that are watching this. What an event, the Super Bowl. And Hewlett Packard Enterprise and Aruba, plus our partners, were instrumental in this. We were instrumental in the world converging and IoT coming together, because we created a full new set of ways that fans could interact with the stadium interact with the fans. New digital experiences. People were finding a wayfinding on their phone to their very seat. They were finding the way to the toilet that had less people in it, or to the kiosk that had the shortest queue. People were watching the videos of a tackle that just took place there, or the goal that was just scored on their phone, sitting in their seat. Plus, they were doing in-seat food ordering. People were, the kiosks were taking the orders off the phones, and somebody would go to the seat and give it to them right there and then. A whole new way of working, which created the new revenue streams. The previous best of $77 per head in a stadium was done at the last Super Bowl, $212 at this Super Bowl, and it was because the people were interacting with their phones more when they were sitting down. They were sitting there engaging with their phones before the game. There was actually a great statistic, and it was the online shop had actually sold out all their merchandise even before a ball was kicked, because people were, I think it was 4 miles outside the stadium, they were able to get the connectivity to the actual network, to the stadium's network, and utilise actually the app and utilise all the benefits that come with that. And it was able to tell them the way to their car park or where their space was, and it built a whole load of engagement up with the customer and the people that were attending the Super Bowl from the very moment, even before they reached the stadium. And the new ways of working was interesting. 5% in food and reduction and food and beverage cost reduction there. And how that was because of machine learning. It knew the amount of people that were coming to the stadium. It knew how many drinks or how many hot dogs or burgers or whatever it was it had to order, or the stadium had to stock, because they could understand the edge. And the edge was, as I go back to it, the people, the places and the things, and it could interact with them and ultimately produce less food that had to be, because it wasn't all going to be consumed, ultimately bring down the price because they weren't having to order in so much more. And just my penultimate slide, right? This is a really good one. I know I'm tight for time and I'm sorry, but edge isn't just one thing, it's an umbrella term, and this nicely puts it together. You've got the human edge, machine edge connectivity, and the edge compute. The human edge is all about the application. Everything's about the application. That's where the data derives from. It's where the data comes from. It's how we interact with others. And without the application, nothing would be able to come about. You think about the machine to be integrated as well. All the different systems that run in that, that stadium, all the different systems that interact with people, from the car park right to the very seat, everything had to come together so it was in the application. The edge connectivity as well, 1,200 access points, all those beacons, all those sensors, sending back data. And whilst that game was ongoing, 10.1 terabytes was transferred over the network. Think about a bandwidth in that small location, which is just a stadium that had to be, controlled and understood and actioned. And we were able to do that through that, those solutions that I spoke of. And then finally, the edge compute. Think about people that were sitting in there, using their phones, watching all the videos going across that network, thinking about data that was getting quickly transferred. We were able to provide that service to them and show them that this is possible. And it wasn't, it wasn't stuttering, it was just free flowing through. And this is the kind of things that Hewlett Packard Enterprise and ourselves are doing. To me, it's fascinating. I like it. I think it's really cool, and that's why I'm in the job, I suppose, and that's why I'm enjoying it. But that's just some of the things. That's just some of the things that are happening. And then finally, I just want to summarise as well, just before I conclude, is that the world is coming together. It is converging, and the way it's converging means a new model is required, and it's this edge model, this edge compute, to understand the machine edge, the edge connectivity, and the human edge, which is the most vital and important. The criticality of devices that are now out there in the world, some of them that we might be working on today or coming in the next few years, these are critical to the world, and we need to have this model to really support those devices coming into the world. And Hewlett Packard Enterprise and ourselves can really engage with that world that is to come, that industrial 4.0, that new wave of the world is going to bring, this new IoT architecture. And we've got the solutions, we've got the hardware, the software, the partnerships, and most importantly, the whole package to provide that to the world that is today. And so, I thank you for your time. It was an absolute pleasure. And once again, I do love a GIF. Thank you.
Thanks, Tony. One thing I was going to ask is, you said about like small companies and like single developers can engage in it. What's the best way for them to use some of the software? Hardware that you guys have?
So again, business to business company that ourselves are, we can operate with yourselves through what we call the channel. So there's a whole host of partners that we work with, again, emphasising the partnership. You know, if you were to engage with one of those partners, then we can quite easily engage with yourselves. You can start using the technology for your own, you know, for your own testing. If you're doing certain applications, you're building applications, you can use our equipment as well to test that and deploy it ultimately for your customers and for their use and services. Of course. So that's a good question. So we do, the model of Hewlett Packard Enterprise is that we are business to business, but there are certain channels that again you can obtain the products from through like our partners. That's one I'll see if we can try and engage with the communities that are here in a different way, and I think through Census we potentially could. So again, working with yourselves, we could look to engage a lot more people here.
Since you were saying that everything's moving to the edge, would it be fair to say that in the examples that you were given, that the edge computing devices were beforehand pushed a set of algorithms or instructions that they would act upon and wouldn't act out of before returning the information to the center or whatever you're going to call it, and that they aren't necessarily doing the full neural network or AI reconfiguring that other vendors and stuff are promising that the cloud will bring to.
Yeah. Okay, so again, another good question. What we're looking at here is, so not everything's going to be moved to the edge. The cloud, I believe, will still be required in some way or another, but a lot more edge devices will be more smart and intelligent. Has that been the case so far? Because everything's been pushed back to the centralised repository, if you want to call it that, that's cloud. It's a good question, and I don't think actually it hasn't been fully experienced, because you think of the cars are struggling right now, or the cars were never apparent. And I just use that example, the easiest one to understand, that the data couldn't all be sent to this central area to be understood in action, because it wouldn't be able to function. And so this new model that's coming down, this new compute element will, I believe, create the next big explosion of devices, or create the next big explosion of interaction with humans and things. Does that answer the question? Is that all right? Again, I'll come back to that.
Is there any more questions, Tom? Right, Tony?
You good? Oh, thank you.
Right, do we have any brave volunteers to get up and do a 5-minute, or not even 5-minute, any kind of talk about projects you're working on, companies you've got in Glasgow, like that? Does anyone want to? Was it?
Do you community plugs count?
Yeah, absolutely. Anything like that, yeah. Just hold that.
Yeah. All right, so hello everyone. I'm William Nelson. I'm currently the events coordinator for the British Computing Society Glasgow branch. So I just wanted to mention some other alternative venues going on. So our session closed last month, but we're going to be running a full session from September onwards of IT and related events throughout the next year that will cover a whole range of topics. We haven't necessarily decided what they are yet. I also wanted to mention that, since I guess most of you are here through meetup.com, that there's also Open Tech Scotland. There's the Open Tech calendar that covers both Scotland and the UK in whole. So there's a lot of other interesting tech events that are going on that you may be interested in. And also, for those of you who are more into open source stuff, there's a really interesting talk happening tomorrow night where someone's going to be showing off their radio telemetry stuff based off of airplanes running off of Raspberry Pis. So a few plugs there.
Great, thank you. Any other volunteers? Anyone else? Yeah. Sure thing.
Hi guys, I'm Andy. I run the local hacker meetup for Glasgow, so I run Glasgow DEF CON, which happens on the first Tuesday of every month. Security is a massive area, especially with IoT, and we're always looking for people to do talks. So if anyone fancies coming along, it's open to the whole, anyone, doesn't matter if you're into security or not, and you're welcome to come along. So it's the first Tuesday of every month in the Raven pub from round about 7 o'clock. Be happy to have you along.
Cheers. Excellent, thank you. That's I'm hoping to have this space. Anyone that's doing anything can have an open forum, stand up and chat. So hopefully folk will talk about the projects they're working on themselves eventually. And community stuff's good as well, sorry guys. But yeah, so hopefully that's what this is for, just to kind of get everyone chatting, and if anyone needs any help, then I'm looking for people to stand up and ask for help from the community. All right, next talk, I'd like to introduce Stuart Kelly from Systolic, who's going to talk a little bit about product design challenges around IoT. So, yeah,
just giving away the end there. Hi everyone, so I'm Stuart Kelly, and I've chosen a very broad topic for my talk, which obviously I can't possibly do justice in the 2.5 hours that Stephen's given me. So I should start this timer here. Yeah, my plan is really just to talk about a few things that I think are common to lots of IoT projects. When I talk about products, my perspective on products is I'm a product development engineer, project manager, so I'm talking most of the time about end user products, so devices that may be installed in factories, in offices, maybe consumer products, but something that's probably an integration of some mechanical parts, some electronics, some software, maybe some optics, maybe some other types of sensors. My background, a lot of my background's in medical device development, and I suppose I've been working in electronic product development for 15 to 20 years, depending on exactly which projects I count. Probably 5 to 7 years ago, started to see product projects that come under the broad topic of IoT, and the earliest of those products was medical devices that were already out there, but the manufacturers were starting to want to put connectivity into them. A lot of that was driven by remote monitoring, remote maintenance, trying to reduce their maintenance costs. And then the logical next step in that is that the new products that we were developing started to include connectivity, Wi-Fi, Bluetooth, lots of options, and obviously the number of options continues to grow. So another interesting development was this was an example from GE Healthcare, where they'd developed a handheld ultrasound system. So you're probably familiar with the ultrasound machines that you might see in a say in a maternity setting, where you're getting a baby scan, and it's on a cart and it's 5 feet high, 2 feet wide. Well, this is very similar, but they'd already reduced it down to a handheld device. So this is looking to be a replacement for a doctor's stethoscope, something that they can have in their pocket, take around with them And rather than just listening to see what's happening, they can actually do scans to a certain depth in the body. And the obvious next step for them was to add connectivity. So this is their vScan Extend device, which is relatively recently released. Fortunately, a mobile phone by itself doesn't have the computing power that you need to do ultrasound calculations, but they've managed here to integrate the calculation technology with everything else that you have with a mobile phone, so display and connectivity. And then the more recent types of products that are becoming very common are products that are sold directly to consumers. This particular example is for strengthening your pelvic floor. Only really women can use this product for anatomical reasons. But there are obviously all sorts of health-related products that are becoming common. I don't only work on medical devices, so I've been working a lot over the last year or so with a Scottish-based startup that are developing this product for monitoring the behavior, the performance of your mountain bike suspension, and then giving you recommendations about what to do next. That's not me on the bike, by the way. I would have fallen off by now. That's one of Danny McCaskill's mates. So, just as I say, I want to talk about a few things that I see as common problems across different product development projects, and hopefully at the end then some of you can give me some ideas on how to solve some of these problems, because they keep coming up in project after project, and I'm sure that some of the knowledge is in the room. One of the things that I really like about my job is I get a lot of opportunities to talk to people about their new project, or maybe a project that they're partway through, but for some reason they've decided that they'd like another perspective on it. And usually the discussion starts off something along the lines of, I've got this really great idea. I haven't got very much money, budgets are very tight at the moment, but really keen to develop this, and we're concentrating on a minimum viable product. And so I think that's a good start to the conversation. So we already have accepted that we need to set some boundaries. And then we get into a technical discussion. We want to have Bluetooth connectivity, we want to have sensor X, sensor Y, we want to get this information together, we want to transmit that to a phone. And so up to that point, usually pretty good. Obviously starting to think, well, the budgets are looking tight, but all of these things exist, the technology exists, so we can put together a project to integrate it. Then the discussion starts to get a bit more detailed and say, well, in order for this product to work, it's going to need to be able to update the software over the air. So that's like a ×2 in the software development cost, maybe. And they say, oh, and by the way, we've already sold 150 devices on Kickstarter. We have to deliver them in 6 months. And we've sold them to 28 countries around the world already. But I think the regulations are quite similar in all the countries, so that shouldn't be a problem, should it? So, by that stage, this is what the inside of my head is starting to look like. These are the questions that are buzzing inside my head. And it's usually about this point that the person I'm talking to says, you're starting to look a bit worried. And fine, but that's what I do. Product development is complicated, and IoT projects are generally quite complicated because it's quite a complex system. And this is when we're talking about a single device, not even a whole factory or a whole stadium. So, as a project manager, my job is to take plus probably half a dozen other things that will be specific to the individual project and try and put that into some kind of structured plan. And depending on where the project is at that point, I mean, one of the tasks is obviously to identify where the project is at that point. This is presented in what's, I guess, usually called a waterfall product development approach. There are lots of agile methodologies which are very valuable, but I think every project at some level, and particularly at the high level, is about doing the right things in the right order. So there's always going to be some kind of staged approach like this, particularly if you've got to justify continuing funding at every stage, which I think most of us do, whatever environment we're working in, whether we're raising money from investors, working within a corporate environment. There's always a number of gates of where we have to justify the project. This is the sort of plan that we'll, and this is quite often what it starts to feel like pretty soon afterwards. This is a great cartoon that I think I've had on my Dropbox for about the last 5 years, and I've been always wanting an excuse to use it in a presentation, so I'll give you a few minutes to have a look at that. Viruscomics.com, I would recommend looking up the website. But yeah, it's very easy for the process to go off the rails, or feel like it goes off the rails, or actually there are often justifications for giving yourself space and time to explore different options. So coming back to the control project, just 4 or 5 different topics I think worth talking about, and then open up to a bit of discussion. So starting from the beginning of the project, concept stage, user experience. I think user experience is critical to the success of the project. There's very rarely that you can deliver a project to somebody, a product to somebody, and they're going to say there was a bit too much lag in the user interface. They're going to say it was too difficult to understand how to use it, or it took 15 minutes to calibrate, and by that time I was bored of it and I didn't use it, or it's something about the way that they experience the interaction. And the thing about user experience, you need to plan it from the beginning, and you need to plan it in quite a lot of detail. I often see the case where the user experience is expected by a lot of people in the project to develop organically. What actually happens is that everybody in the project has a slightly different vision for what the user experience is and what order things are going to be done in. And if you haven't planned it out in as much detail as possible at the beginning, then that, the implication of that is that you spend 10 times longer later in the project. So I really encourage mapping that out in as much detail as you can. Use whatever tools. It doesn't have to be particularly complicated tools, but flowcharts, documents, whatever you personally are happiest working with. There are loads of free tools for simulating app interfaces in relatively easy way. PowerPoint is good, and even using multiple tools and coming at it from different angles. Getting all that definition early in the project is going to make a huge difference to how efficient the project is later on. The next area where I quite often see difficulties, challenges, misalignment is in the interface between the device itself and the smartphone or whatever device your app's running on. So whenever I go to sort of technical trade shows, I try and talk to as many app developers as possible, because they're a resource that are quite often important in projects that I'm doing. And so usually get the initial sell, and it's all about we map user experiences, we connect with servers, we can design really nice looking phone apps. And then I ask about, and do you have much experience of interfacing with custom-made devices and custom sensors? And probably about 10% of the time I get a yes, about 90% of the time I get a yeah, we could do that, no problem answer. And so well, what would you need to know to do that? And so, well, yeah, as long as your embedded software developer can give us all the details of the interface, then we'll be fine. We can work very easily on this. So I think, well, that's good. And as a project manager, obviously thinking, what can I delegate? So I'll go back to the embedded software developer and say, well, all they need is to know all the outputs. And they say, but I want to know what they need as inputs to their app development. So basically I'm getting the same story from both sides, that the embedded developers want the app developers to tell them what they need, and the app developers want the embedded developers to tell them what they can have. And obviously it's not that simple, because there are decisions to be made at the system level about what processing and what preconditioning of the sensor signals do you do on the device, what does it make sense to do on the phone or to send off to the cloud and get some analysis done. So I mean, that's the really big area where I'd really like to hear ideas and examples of how people have done that and how people have addressed that problem, because I think it's not a very visible problem, perhaps, and I'm sure there are solutions out there for that. Next thing is packaging. Packaging is not specific to IoT projects, but one thing that happens with packaging usually gets designed about here. So you've made about however many hundreds of thousands of devices, and then somebody remembers that they need to design the packaging. Why not design the packaging much earlier on? One of the things with a device like this is you're probably going to have to send them out for testing, you're probably going to send them to users, you're probably going to be shipping loads of devices during the development process. And if you only find out at this stage here that the packaging that you've designed doesn't protect it properly from shocks or from the way that shipping companies treat the product, then you've lost that chance. I mean, packaging's easy to design, just plan it into the project at the right stage. So that's just a bit of a pet subject. The next thing at detailed design, which is essential, is some kind of compliance testing. So there's quite often a belief, or I don't know exactly where it comes from, but there's quite often a belief that if you choose an approved module for your device, your embedded device, so if you choose a microprocessor that has a Bluetooth capability and has an antenna on it, that you then don't need to do any more compliance testing. And unfortunately that isn't true at all. But I regularly speak to people who've got that impression. I don't know whether it comes from the device manufacturers. So it is certainly worth choosing devices which have been tested by the manufacturers to prove that they emit radio signals that are in the required area. But you still need, whatever your device is, you need to prove that your final device is safe, that it doesn't emit electromagnetic radiation across the whole spectrum, not just across the radio band, which is above certain limits, that it isn't affected by electromagnetic radiation from other devices, and also that it meets the radio regulations. And especially in Europe, there's the Radio Equipment Directive, which becomes compulsory, I think, from about 2 weeks' time. And that's, by definition, going to be applicable to most IoT devices, because they've nearly all got some kind of radio in them. But one thing to watch out for is that the low voltage directive didn't apply to devices that had less than around about 30 volts. But the radio equipment directive applies to your device regardless of the voltage. So even if you've got a 3-volt battery in there, you're going to come under that directive and you're going to need to do all of that testing. And it can be quite significant cost. So think about that. Obviously, if you've got a medical device, you've got the medical device directive as well. There are directives for other types of equipment, but the RED is going to be applicable regardless. And then the last thing I wanted to mention is, once you get into manufacturing, it's very important to think about how you're going to test your device. And this is particularly an issue for Internet of Things devices, because if you think about what are the important things that you're going to need to test before you're prepared to ship your device to the customer, that radio communication is going to be pretty high up the list, because if they take it out of the box and it doesn't talk to their phone, they're going to be quite disappointed. And it's much better to find that out at the factory than to start having lots of devices returned to you from the 28 countries around the world where you've sold your devices. I mean, things that are devices that have got 3G capability, and then you try to have it manufactured in a factory in an area where there's no 3G signal. But even Bluetooth, you have to think about how are you going to test that? Are you just going to give the factory an iPhone, or do they have to invest in some kind of equipment that might be a £10,000 investment? Because if your manufacturer isn't already manufacturing exactly the same product, then they probably don't have the test equipment. Even if they are manufacturing the same product, that equipment may well have been supplied by their other customer, and it wouldn't necessarily be available to you. So don't make assumptions about it. Think about what you need to test. You obviously, I think for any product, you can fairly quickly write down a list of the things that you'd really like to test. You might cut that down to the things that are absolutely essential to test, but then you need to come up with a method to do that. So, I think interested to hear if you've got any ideas on any of these areas, or even just experience to either back me up or completely contradict me. It's just my contact details here if anybody's interested in discussing any current or future projects, or I'm often on behalf of people that I'm working with looking to put together development teams. So if you work in any of these areas and do that on a sort of contract basis sometime, then interested in knowing that you're right there. Thanks very much.
Stuart, what would you say is the most underestimated part of the process people come through?
Software development. Probably, all aspects of software development, but the amount of effort that's required in the embedded system to get it working as you want it to. So, quite often you have to do a lot of work that maybe isn't obvious to reduce the power consumption of a sensor, understand what the data sheet's actually telling you, get in touch with the sensor manufacturer, see how did they actually achieve the 2 nanoamps of current that they have in the data sheet as opposed to the 25 milliamps that you're measuring. And that's what you need to do to get the battery life up to acceptable level.
And do you think the cost as a scale up, it gets more expensive, or is it that software from right at the start?
Well, the thing about software is it's very easy if you don't have a lot of sort of discipline within the team, and by the team, also, this is also the product team. If you don't have a lot of discipline, then it's very easy to start adding in lots and lots of functionality that maybe you didn't plan for. Maybe you're starting to get to the limit of the code space that you've got available. Maybe you're actually starting to just go beyond the limits of what you originally designed for.
When you were talking about user experience design, do lots of companies ever bother to do use cases and the case examples of working out how they'll actually use it and going through all the diagrams and all the pathfinding and all that kind of stuff?
They usually do by the end of the project, because usually eventually there's some kind of realization that without doing that, your developers can't really do their job. But quite often at the beginning of the project, there's maybe you're thinking about the main use case. So if everything goes well and everything goes to plan, then this is how it will work. But you need to think obviously about what else could happen, what happens if you lose connection halfway through, what happens if they enter enter some data that's not what you want, until the battery runs out, and also the who are the other users apart from the main user. So, is there a maintenance user? Is there, or in a hospital, are there people with different access levels? And I'd say very few people actually do that to the necessary level of detail beforehand.
At which point do you start to consider the security of the device? Is it at the beginning, whilst the idea is being made, or is it like once you've got a pretty box and some point of view, is it a byproduct, or is it built into the idea?
Yeah, ideally it should be at the beginning, and it should be part of the. I can go back here. So it's part of the feasibility and system design stage. So the feasibility may be very focused on the sensors that you've got, and can you get the sufficient resolution of the measurement for the application that you have. But the early stages of the system design, you would be looking to have some kind of risk assessment for the product as a whole, what could go wrong, and that definitely should include security considerations as well as sort of more obvious safety things like electrocution and water ingress.
So you wouldn't recommend doing it 3 years after product release when it hits the news?
It depends how much excitement you like in your life.
Because most of the big famous IoT hacking, things like camera, the thing that happened last year in America,
Yeah.
cameras, and that was found it was just full design fault. It's programmed with like the same password as a million devices, and that was like a complete design error at the start, which caused a massive problem. And that's it's all about designing at the very start for security and making sure that you know exactly what's happening.
Yeah, I mean it's quite easy, especially in regulated markets, because there aren't a lot of security standards at the moment. It's very easy to focus on the things that you have to do, the safety and efficacy things that somebody's going to actually test. You're going to have to submit some results on that, but security should be equally important, and I think over the next few years it will become of a kind of equal level with new standards appearing.
What are your thoughts on the device maker's responsibility towards supporting their device, like long term, more than just like a couple of months or a year, and whether or not they should consider supporting like the firmware and software of the device over a long period of time?
Yeah, I think it depends a lot on the device and the kind of implicit expectations. So in the medical device world, there is an expectation that if a hospital buys something, then it's probably going to be supported for 10 years, and historically things have probably lasted 20 years, but that's, I think, going to become more difficult with the digital aspects that are added in there now. Whereas if you have a consumer product, then maybe your minimum viable product you don't need to support, but you should make that clear in some way, and then maybe there's a professional version of it, a more expensive version of it that comes with an expectation of support. So I don't think there's necessarily a moral obligation to support it, but I think it should be part of the expectation around the product and part of the initial specification, I suppose.
Can I ask that question to everybody earlier about disparate teams and how you kind of decide on who does what? I think we're talking about maybe app developers and device developers. My view, that's one of these areas where I don't think there's a silver bullet as part of the design problem, because you've got this thing that's like, yeah, there are lots of columns, I can put this piece over here. Oh, columns are constrained, but I've got the CPU, I better put it here. But when you've got disparate teams, I think the really important thing is communication and just making sure they're talking a language they both understand. I don't have a good example from the one you're talking about, but my last company, a software company, building recommendation engines, we tailor it for the TV company. So you're having to talk to these business types in marketing. And we had a business rules engine, and we kind of marketed it as something like, hey, you can change this yourself. But that was BS. It's like, you need software engineers to change the rules engine. But it was a really good communications tool, because you could put something up that was fairly formal, sides were kind of agreeing on it, and they knew this is a case of the business people weren't actually implementing anything, but they were, both sides together were designing the product and saying, right, this is the outcome. They agreed on something that was formal enough, but clear enough that both these disparate parties can understand. But it's just the whole thing's a design optimization problem. You're trying to say, like, what's the best solution here? You just have to apply brains, but communication's important.
Yeah. So I mean, completely agree with that. The solution's often to get everybody together and try and get everybody aligned on the end goal. I suppose I was interested in whether there are any tools out there that are specifically at that kind of interface as well, because it seems like it must be quite a common problem. Is somebody specifically looking at that?
A lot of stuff from university trying to apply. We've got a department at DMEM, design, manufacturing, engineering management, and they kind of do a lot of this stuff. And it's possible there's people there that are kind of looking at these design and management type issues and saying, well, how do we resolve this for multidisciplinary teams? If you haven't spoken to them, it's just talking.
I know a few of your colleagues, but I'll maybe carry.
Any other questions? Stuart, thanks again.
Nice.
I'd like to thank Tony and Stuart tonight. Also the Tontine, Census, Stream and Product Forge as well that are recording it, and they're going to put the link online if anyone wants to see any more of the presentations again. The next meetup's going to be towards the end of July or August. The date's not firmed up yet, but I'll put it on the meetup website and you'll all get the message there. If anyone's got any ideas for speakers or anyone's wanting to speak themselves and do a slot, please email me through the meetup website or chat to me afterwards. We're always looking for speakers, so if anyone is doing anything or thinks they'd have a relevant subject to talk about, please come forward and chat to me. But we've got the space until 9 o'clock tonight, so if everyone moves back through to the other area and can have a few beers and have a chat about various things. Right, thank you.